Good evening, guys. I'm Parth. I work upstairs. I lead the data science group in engineering, which is our group that does machine learning, natural language processing, and search projects. Before I started doing that, I led the search effort, and that's what I'm going to talk about. So most of you know what Bloomberg is, so I'm not going to. Does this work? Okay.
Should work.
Great. Most of you know what Bloomberg is, but I'll talk about the kind of data we work with. So we work with anything that moves the markets. And that, as you hopefully have learned today, is a lot of things. It could be foot traffic somewhere. It could be a tweet. Could be a news story. Could be a tanker that is delayed getting to Florida because of storm in the Caribbean. So by the definition of financial markets, the data is diverse. And because of that, the kind of people who use this are very diverse. So what does that do? How does that matter in search? So everybody knows search. Everybody knows web search. Google is great. The thing is, most of the internet looks the same. They're all pages that are linked to each other. Whereas due to the diversity of the kind of data we have, search means different things to different people. And since the market we work with is a very limited number of people who do what they do. And the kind of product we have, which is a premium product, so the people who use this are the experts in their domain. And these are the people who do weighty decisions based on very quality data. All this matters because we are working with a very diverse data set with very different use cases. So a lot of the luxury that other companies have, like doing large-scale machine learning based on massive amount of usage data, or doing large-scale A/B testing to decide which model works better, doesn't work for us. So I'm going to talk to you about a few things that we ended up doing to get around it. But the most important part, I think this will come over and over as I talk, is precision is important. The decision of putting the right result at the first result is very important because now you're not losing 30 seconds of your time looking at a wrong picture. What you're losing is probably a large amount of money. So let's talk about search. Search is, as I said, it's a very different thing. I want to talk about one kind of thing, which is the unified search that we made for the terminal. We want to do what the web searches did to internet. If you remember the internet before Google came along, everybody had bookmarks. My bookmark folder was 20 deep and 10 wide. And once Google came up, nobody has bookmarks because you don't really need to remember where the data was. What you need to remember is what you're looking for. So that's what we wanted to do for Bloomberg. So whether you are looking for a keyword or you're looking for an idea which can be described in a natural language sentence. For example, find me all companies that are part of S&P and have bought companies in Asia and have issued investment-grade bonds. I don't know what exactly the use case for that might be, but if you wanted to search for that, we would search it for you. And all you had to do was to type that sentence. And we want to get to a place where you can search all that in one screen, and we will give you that information in one single ranked list, so you don't have to learn more and more different places to search for data. Why is that hard? Because A, the data is diverse, B, the precision is important, and C, the number of people who use this or use this in a very unique way is small. So a lot of things that companies can depend on simple mathematical models and a large amount of data, we have to solve more creatively. So how did we end up doing this? We use open source, in this case Solar, which is an awesome, super fast search engine, and we use a lot of machine learning. We have, in the last 3 or 4 years, worked extensively on Solar, committed heavily back to open source. I think about last 15 or 16 versions of Solar have had some sort of our code in it. And I'll talk to you about a few of the things that we have done for Solar in the last year. we use machine learning, and I'll talk to you a little bit about that. So this is how a search pipeline works, right? You type a query, you process the query, and processing could be spell correction, processing could be putting synonyms, New York becomes NYC, things like that. Then you send it to a search engine. It gives you back some top documents. Then you get features out. Features are attributes of your documents. That could be how old the document is, how many people have clicked on it, etc. And then you re-rank it. And then you present it to the user. So what we're going to talk about mostly is the re-ranking part today. What does re-ranking mean? It's basically how different are your results to what people are expecting. So let's get a little more technical, right? So when you send a query to a retrieval engine, it gives back a set of results. And those results are weighed by something. And that something is basically a combination of weights of a different attributes and those attributes themselves. Example could be the attribute is where did the query match the document? Was it in the title? Was it in the descriptive text? So you assign some sort of a weight to that attribute, and you calculate a score, and you rank that by that score. If you do it manually, it gets tedious. It gets tedious because, A, you need to know a lot about how your data is organized. And for our search engine, which works on about 60 different kind of data sets, structured, unstructured, and real-time and not, it sort of becomes unwieldy and not scalable. Plus, you need to assume that all data is sort of mixable, which is many times not. So you do machine learning for that. So now I'm going to hit you guys with some math. If you're going to do machine learning, you need a metric. And for any information retrieval task, you use a metric called Normalized Discounted Cumulative Gain, which is a mouthful, but it's very simple. It basically, think of it like a weighted average, where you are punishing clicks on lower results more, exponentially more as you go down. So as an example, think about these two behaviors. The one on the left has 0 clicks on the top and some number of clicks going down, which is not ideal because you want most click on top. So a proper sorted version would be like that. So that's your NDCG. That's a metric that you want to increase in search. So now you have the metric. How do you increase that? There are multiple ways to train a model to do that, which is called learning to rank. That's the machine learning word for it. The one we use is called LambdaMark, which is based on decision trees or regression trees, actually. Again, this is a bunch of math. I'm not going to go into it. I'll be here if you guys have any questions afterwards. But if you're familiar with decision trees, think of them as a whole bunch of them stuck together, where you are scaling the output of the first one by how much impact it has on your metric. So this is what you do. You basically train a tree, scale the output, send it to the next one, and keep doing this. It's your standard gradient boosted decision tree, but this is the regression tree version of it. And at the end, what you end up with is a set of trees, and that's your model. So when you actually get a query, you run them through the trees, and you simply add the score up. So since this is a tree-based model, it gives you some advantages. It lets your features interact. And what does that mean? What it means is that if you have different attributes of your documents, not all of them are independent. So for example, a source of the document or the type of the document may have a relationship with how the age matters of the document. Right? For example, a movie review might be good if it's old. Stock review might be useless if it's old. Right? So, and especially when you have engineers and machine learning scientists making a ranking function for financial document, which is not their forte, having an advanced machine learning model that can do feature combinations is very helpful. It also can rank data sets of different sizes for that exact reason, because it can use size as one of the features. We had a huge improvement once we started using it. But more than that improvement, the good part about learning to rank is it always continues to improve your model without constant need of people tweaking it. So this is what we started with. So we figured, why have re-ranking as a different step? Why not push it inside the search engine itself, inside Solar? So that's what we ended up doing. We took our machine learning code, the online version of it, and pushed it inside Solar. And the advantages are quite a bit. First of all, if it's in Solar, everybody can use it. So that's the advantage to not just us, but a lot of us. It's maintained by the community. But also, it gives you much richer features, because now you are in the matching part of the search. So you can use phrasing, phrase matching, you can use stemming, things like that to do your ranking. And also, it reduces the hop between two services, so your performance gets much better. We released it a few months ago. That's the URL. Or if you just search for Bloomberg Learning to Rank plugin, you'll find it. It's part of the Solar query, the model of the feature extraction model, as well as the ranking model, are managed as Zookeeper managed resources. Again, I can talk more about it at the end if you want. So one last thing, because before we stop, how do we test it? I said consumer companies have the luxury of doing large-scale A/B tests. We don't, and we don't because A/B tests assume that all users are more or less the same, and they all kind of have the same idea of how they should use the functions. For example, if I give you Pepsi and I give somebody else Coke, and if you like Pepsi, it doesn't mean you hate Coke. You just like Pepsi at that time, right? So that's the problem that this thing called interleaving tries to solve. The other problem with A/B tests is it needs large amount of data before you can converge on what's a clear winner. Interleaving is an idea that often used in search engines, where instead of giving you a can of Pepsi and a can of Coke, I would give you a series of glasses. Some of them would have Pepsi, some of them would have Coke, and I would know which one is which. And based on what you choose, I would give more points to that model. There's a little bit more of science to that. We won't get into that. So that's what we use to decide which model to push out. Lastly, here's a couple of things we pushed out last year. Here are a couple of people who worked on our open source projects. And that's my friend Dave dressed up as Hulk, because he likes to think of himself as Hulk. If you have any questions, I'll be here.
Thank you very much. Why the choice of Solar as opposed to, I don't know, Elastic or other frameworks?
Yeah. It's a great question. I think it came down to a couple of things. One was we were looking for something that was truly open source, where we had a lot more control over open source and source code, and a lot more say in how the direction goes. Elastic is an awesome product. It's very easy to use, and they're both based on Lucene, so they are both really, really good products. But the thing about Elastic is it's a product that is geared towards a company supporting and maintaining it. You can see the source code, but it's not the same as a wild west of a true open source software, right? So it's like, the joke was that some people like the Beatles, some people like the Stones, we like the Stones.
That's awesome. All right, we have one question here. Somebody who hasn't asked a question yet.
Hi, thank you for the presentation. That was really good. A question I have is, a lot of times you build, as a data scientist, I'm a data scientist, you build models and then you ship it out to your customers or clients or whoever, and then they have great results. But then you come back and your data is constantly changing and you have to maintain it and productionize it. And that's always been a challenge. How did you deal with that in your Learning to Rank project?
Yeah, so when you say data, you mean the data you
built the model
the model with,
yes.
Right? So that's hard, right? That's a problem you deal with on a daily basis. So the rule of thumb that we go with is you have to have good and constantly evolving regression tests. And unless the quality of a new model matches or exceeds the quality of the previous model with the evolving regression test, the models don't go forward. So that's sort of the necessary but not sufficient condition. You have to have that if you want to productionize it. But the other thing is your data, the training data has to constantly evolve. You constantly have to get better training data. It's a little easy with information retrieval tasks because implicit data is very important, right? So we use heavily anonymized, aggregated click data. But with other tasks, it's a little harder where you have to get, if you talk about classification, if you need HO, I guess, user judgment. And that's harder, but there isn't any way around it. I think you have to continuously evolve your training data.
So you need to build a team where a data scientist can actually maintain and productionize also.
Absolutely. Either that or build a pipeline where you are automatically collecting data based on how good or bad your results were.
Thank you.
One here, and then we'll go around to that.
Hi, just to get a perspective, this is purely for the terminal searches, or this is for terminal and web?
Searches.
So wouldn't they be pretty low in terms of volumes, because there's just 300,000 terminals for this kind of user, sophisticated user? We would expect maybe close to 1 million searches a day.
Yeah.
So that's a very low number to base a model on, like for an ML learning model.
Yeah,
right.
That's
And
exactly
is that why the interleaving part made more sense for you?
Yeah. This is exactly it.
Okay.
I think on a good day, we are talking about low 100,000.
Right,
days,
yeah.
And that too have a very, very long tail.
Now, would this have a similar use case in intranet-based web searches for enterprises outside, meaning, let's say, a financial services firm wants to make the internet better? Would they be able to use the Solar product and then try to get a use case solidified in similar way, because they also don't have many intranet searches?
Yeah. Yes and no. So I think they would be able to certainly build something with that, but the ranking model would have to be their own, because the ranking model are inherently tied to the data. So what we have is, if you have log data, and if you have data of what people are searching on and what they ended up clicking, if you have that, what we have built is very easy to bootstrap something with that and getting started. Of course, the models themselves won't work right away, but.
Hi. Thanks for that talk. Just curious, the complexity of the searches that you mentioned in terms of the use cases.
Yeah.
It seems like most users know the function that they want to search for. So, for example, the screening that you mentioned for the bonds, someone would know, hey, I want a screening tool. I don't need to put all those things in the search function. So are you making this more complex than it needs to be? Like, aren't users searching for the function without the details of the function?
It's so what happens is you may know the bonds function, but what happens is when you want to search for, say, ships that might affect the companies that you're interested in, then you have to learn a new function that will let you search for ships. Or if you want to search for just equities, then you have to find a different screening function. So what we are trying to do is not to replace any of the functions. What we are trying to do is to put a layer that will have a single point of entry for all those functions. So the result comes from the same exact searching screening backend that you talked about for bonds. But what we want to do is to kind of remove two needs. One is for you to actually know that a bond screening function exists, and this is how I use it. And second is for the need for you to fill out a form, like fill out 5 combo boxes. If I can let you type 7 words instead of filling out 5 combo boxes, it's going to be much faster.
Yeah, and anybody who's been a long-time user of Bloomberg will attest to the fact that discoverability is something we're still working on. I'm on, and I work in BI here at Bloomberg. You know, I'm the guy who uses the S&P, looking for companies that issues bonds.
Right.
So I'm that guy. What happens in sort of an engine like this when there is an exogenous event that spikes data and changes not only the coefficients in the equation that help improve the acronym score, but also changes the number of items in the equation itself? How do you account for that? And particularly when we're doing regressions all look very, very nice when the data is smooth and you had quote unquote normal markets. But when things go haywire, how do you readjust? Thanks.
That's a great question. There is a few things we have done. It's not a solved problem. We're still working on that. We have a few things we have done. There is a whole field of information retrieval called online learning, which helps you a lot with learning from very small amount of interaction data. So, and it takes you to bandit algorithms and things like that. So that we use those to deal with new kind of data. So when you said the factors themselves are new, so when you get new kind of data, that's the kind of algorithms we used to deal with that. A sudden spike in popularity or sudden spike in something so that the value of coefficients need to change fast. Online learning helps with that, but sometimes not. But the good thing is, since so one of the things we search for in Bloomberg is news, right? And news has our back many times. So if there is something spiking, there will always be a very hot news story about it. And so as long as you do the news search well and do the time degradation well, kind of saves your back most of the time.
Great. Last question.
Hi. How many of your applications or answers are unsupervised learning? Because there is a supervised learning piece of it, which is the models. Right. Do you answer any of your business questions using unsupervised learning?
That's a great question. It depends how you say we answer. We do use unsupervised learning a lot, but that's not really to directly answer any particular question. We use unsupervised learning a lot to sort of bootstrap our data. For example, word2vec, right? It's a perfect unsupervised learning algorithm. We use that a lot for query reformulation and all that, but it's a little risky for something as high precision as us to depend on purely unsupervised methods. I would love to if we could, but yeah, absolutely. Right. Yeah, for our use cases, mostly because of the requirements of explainability and precision. So.
All right. On this note, thank you so much. It's terrific. We enjoyed it. Thank you.